So good morning guys. So today let's talk about an alternator. So first, define an alternator. So an alternator is an electrical generator that converts mechanical energy to electrical energy in a form of alternating current. So sagara nanto makita ang alternator sa mga sakyanan. So an alternator is a generated of electrical power in a car and is a major components of the vehicle charging system. So importante kani siya sa usa ka sakyanan. So all cars with an internal combustion engine except for some hybrids have an alternator. When an engine is running, the alternator charges the battery and supplies the additional electric power for the vehicle electric system. So ang alternator daimon is ay mukuan kung magkuan ang engine siya, kung mag-start ang sakyanan, so ang alternator mo charge sa battery. So an alternator is a maintenance free unit. So in some cars it can last up to 10 to 15 years without any repairs. So nindot gyud ang alternators kay long lasting gid siya. So if an alternator fails, the car may still running for a short of time on the battery power. So kung paong ang alternator, so mudagan gyapon siya kay napamantoy sod ang battery niya. So once nga mahurot na sa tong battery, kana dili na gina mo andar. So however, the engine will still as soon as the battery charges is depleted. Replacing an alternator with a new OEM part is expensive, but there are alternatives. So ingana kay importante ang alternator sa usa ka sakyanan. So parts of an alternator. So we have a pulley, sa natay bearings, natay housing, natay rotor, stator, rectifier, nya voltage regulator, nya protective cap. So ato ni silang ilaylahon. So first is the pulley. So the pulley function is to rotate the rotor assembly as the engine is running. Yes, the pulley works as a connector between the rotor assembly and the engine through a drive belt were known as alternator belt or serpentine belt. So second is housing. The housing function is to protect the inner parts of an alternator, become a household of them like stator, bearings, rectifier, and so on. So the bearings function is to make the rotor assembly rotate freely. The attached in front of and at the end of the rotor shaft. They support the rotor shaft so that the rotation runs smoothly and freely. So gamit yun kaning bearing. So the rotor assembly function is to generate magnetic field. The electromagnetic force were built up because of the electric current flows from the battery through the rotor coil. So the stator assembly function is to generate electric current as the rotor assembly cuts the stator coil. The stator is a stationary set of windings that surrounds the rotor. So the coil built in rounded shape so that the rotor assembly can rotate inside the stator coil. So rectifier. So the rectifier is used to convert current from the alternating current AC to direct current DC. So during the charging process. The next is voltage regulator. So the next part of alternator is the voltage regulator. So the voltage regulator controls the amount of power distributed from the alternator to the battery in order to control the charging process. As we mentioned before, more faster the rotor rotation, it's increasing the electrical current were generated in stator coil. So kung mas kusog ang tuyok, mas dako ang current nga mahatag. So the voltage regulator is used to control the output voltage. So protective cap. The protective cap is used to protect the rectifier components were placed outside of the rear housing. This protective cap is depends by the alternator maker, so nagdepende ra siya. Some makers did not use protective cap but they put all the parts inside the alternator and just leaving thermal B plus B and socket. So optional na din siya, depende sa kanang maker. So natay schematic diagram, manitang schematic diagram sa rotor. So natay stator, madto siya sa battery. Ang stator madto sa rectifier nya through the battery, nya to the ignition switch, warning light, to the rotor. So the money pictorial diagram kani kay schematic diagram ug pictorial diagram. So natay kanang alternator mupadong siya sa battery, ang battery mupadong sa ignition switch. So let's proceed to the formula. So now let's proceed to the formula. So we have generated EMF per phase. So EP equals to 2.22 K sub P K sub B F lux Z. Yeah, pitch equals to coil span in numbers of slot over slots per pole. Yeah, Kp equals to sine 90 degrees pitch times pitch. Yeah, Kb equals to sine n torque angle over 2 over n sine torque angle over 2. So ang torque angle is equals to 180 degrees over slot per pole. E sub P equals generated EMF per phase. K sub P equals to pitch factor or distribution factor. K sub B equals to belt factor or distribution factor. F equals to frequency or hertz. Flux equals to flux per Weber. Z equals to number of conductors in series per phase. N equals to number of slot per pole per phase. We have frequency of the generated EMF. So F equals to Pn over 120. So F equals to frequency. P equals to number of poles. N equals to number of rotors rotation. Next is generated EMF per phase, electric current, electric circuit relationship. So we have E sub P equals to square root of V sub P cos theta plus I sub P R sub P squared plus VP sin theta plus minus X sub LA squared. We have A equals arctan V sub P sin theta plus minus I sub P X sub LA all over V sub P cos theta plus I sub P RA R sub A. AP is equal to generated EMF per phase or volts. VP load voltage per phase. I sub P equals to armature current per phase. R sub A equals to armature winding resistance per phase. X sub LA equals to inductive resistance of armature winding. We have here N equals to P sub out all over P sub out plus P losses, P sub losses. So P out equals to V sub L I sub L sin theta. P sub out equals to I sub P squared R times RA. P losses equals to P sub Cu plus P sub Fw plus P sub 4 plus P sub F plus P sub V. Natay P sub out 30 theta equals to square root of 3 V sub L I times I sub L times cos theta. We have also P out 3 theta equals to 3I P squared RA. PF is equals to IF squared, RF is equal to IF times VF equals is equals also to VF squared over RF. Yeah. I IF kay line circuit niya, IV equals to phase current niya, cos theta equals to load power factor niya. P CU is armature winding copper losses niya. PFW is a friction and windage losses niya. P core is a core losses niya. PV is ventilation losses niya. PF is field winding niya. IF equals to field current niya. RF equals to field resistance niya. RA equals to armature resistance niya. VF equals to voltage across field winding. So now let's solve one problem about an alternator. So let's proceed. So we have here a problem. So an alternator has 9 slots per pole. If each coil spans its 8 slots pitches, what is the value of pitch factor? So let's write the number slot of pole, number of slot per pole is 9. Yeah. Each coil span spans 8 slot pitches. So K sub P is known. Ano ito pangitaon? So slot angle equals to 180 degrees all over number of slot per pole. Number of slot per pole. So we have 180 degrees over 9. So we have 20 degrees. So next is coil pitch equals to 8 times 20 degrees equals to 160. So 180 degrees minus 160 equals to 20 degrees. So pitch factor Kp equals to cosine B beta cosine B mo na siya itong B beta over 2, so equals to cos 10 degrees. So ato gamit tag calcio cos 10 So Kp na to is equals to 0.985, and that's our final answer. So that's it.